10 as I approach it from the other side. Kendrick, as x approaches -3 from the left, what's the graph doing? Yeah, it's going to infinity. It's going up. As I approach it from the right, Rebecca, what's it doing?
Negative infinity.
Yep, it's going down. Justin, what's the domain?
Negative infinity to -3, -3 to -2, and -2 to infinity.
Yep. That is a negative. Good job. And then, Jenna, what's the range?
Negative infinity to -1, -1 to 2, and 2 to infinity.
Excellent. Good job. Y'all got this. Questions? Okay, so now we're just going to draw the conclusions. So based on all four of those things, all four of those graphs, if the graph of f of x approaches a number, as x goes to infinity or negative infinity, then what does that cause? So that's this. As x approaches negative infinity or infinity, and it's approaching a number, what is that number? What is that in the graph? The horizontal asymptote. So the graph has a horizontal asymptote. And these are things, when we get to calculus, we'll just take it just a little farther. We'll include limits with it, but that's how we'll define a horizontal asymptote. It'll have to do with x approaching infinity and negative infinity. Okay, so if f of x approaches a number, as x approaches a number from the left and right, then what, so then we're talking about the second part here. So what is that in the graph? It's a hole, yeah. Also called a point discontinuity. Same thing. One's a fancy word and one's not. And the x was a, so it's a, b. Okay, so now the next one. If the f of x, so the y part, is approaching infinity and negative infinity, or either one, as x approaches a number from the left or the right, then what's that number? That's the what? That's the vertical asymptote. That's at x equals a. I guess up here I should have said at y equals a. More specific. And so 4 and 5 we already talked about. I think I might have even written it out on another set of notes. But to find the domain, it's negative infinity to infinity, except for what?
The whole, but that's
the x-coordinate of the whole. And what did you say, Berkeley?
I said the restricted value.
Yeah, okay, yeah. So x-coordinate of the whole, which is one of the restricted values. And what's the other restricted value that comes up? Yep. And the vertical asymptote. Now, if you don't have either one of those, then obviously you wouldn't exclude it. But, you know, if you didn't have the whole, then you wouldn't have to worry about that. So the range is negative infinity to infinity, except for what? Yep, horizontal asymptote. And, if they have it, the y-coordinate of the whole. or the point discontinuity. Okay, so we've been doing these all with graphs or equations. We did a lot of work with the equations. That's what we've been doing before. But we never really talked about tables, which is what's going on here. So we should be able to also apply these same properties to a table of information. The same things are going on. So I believe there's a couple of them. Yeah. So this first one we'll walk through slowly. First it says, identify the equation of any horizontal asymptote of the graph f of x, give a reason. So let's look back up here. Horizontal asymptote. So horizontal asymptote is if y approaches a, f of x is the same thing as the y coordinate, as x approaches negative infinity or infinity. So that's negative infinity is this way for x, and positive infinity is that way. I know it's an actual number, it's negative 500, but it's getting bigger and bigger and bigger. Obviously, in a table, we can't show infinity in a table. Yeah, we can't. So, are these two things approaching close to the same number? Yeah, what would that number be, you think? The x's are negative 500 and 500. What about the y's? 1.5. Excellent. So y equals 1.5 is the horizontal asymptote because we're supposed to give a reason. As x approaches negative infinity and as x approaches infinity, f of x approaches 1.5. Now there were like 1.499 and 1.501, and if we went maybe to, say, negative 1,000, this might be 1.4999, and 1,000, this one might be 1.5001, but we can tell it's getting closer and closer to just 1.5. And that's a horizontal asymptote. So that's when the x's max out, it's leveling off on both sides. B, identify the equation of any vertical asymptote of the graph. So let's go back up here and look. A vertical asymptote is when y, or f of x, is approaching a really big or a really small number, that's infinity and negative infinity, as x equals a from both sides. So, do we see something that's approaching a really big and really small number on either side? Say that again.
500.
Oh, yeah, okay. Oh, that's the x's. I mean on the y's. Really big, really small number on the y's.
Negative 248.
Yeah, these two. That's not negative infinity, obviously, but that's a negative big number compared to all the other ones, and a positive big number. And those are getting closer and closer to this. Notice it's undefined at that point. It should be, because that graph is not actually going to reach those vertical asymptotes. It would be undefined at those points because you get 0 in the bottom of a fraction. So, x equals negative 1/2, or if you put negative 0.5, same thing, is a vertical asymptote because, I'll leave you hanging. You have to come back to find out why. All right. See you tomorrow. You could probably start on the assignment. And it would, I mean, you probably can't finish it, but you could at least start on it.